Hey there, my name is Suhal and I'm going to teach you all about input-output handling approaches. So what is the input-output handling approaches? Well, in definition, input-output handling approaches are methods to synchronize transfers between devices and ensure correct timing of action. There are two input-output handling approaches, which are program-controlled and interrupt-based. In program-controlled, the difference in speed between the processor and the input-output device creates the need to use signaling protocol to synchronize the data of transfer between them. So how does signaling protocol in program-controlled input-output works? For the input, so let's bring out the keyboard and the processor. The keyboard stores information to a register called keyboard data. A kin flag, which is the signal that a character code has been placed in the keyboard data, is initially set to 0. The processor is constantly checking for the kin flag to be 1. When you enter an input from the keyboard, for example, when the letter A is pressed, it is added to the keyboard data register, and the kin flag will be set to 1. Now that the kin flag is 1, the contents of keyboard data is transferred into a processor register. After the contents are transferred, the kin flag is set back to 0. And now that the kin flag is 0 again, the keyboard data is ready for another input. Now for the output, so let's bring out the processor and the display data. The processor attempts to pass the information received from the keyboard data to the display data, but is stopped by a status flag called Mr. Doubt. Mr. Doubt tells the processor that he has to check whether display data is free first, before he can allow the processor to pass the information. Mr. Doubt calls display data to ask whether she is free. Display data tells Mr. Doubt that she is free and she can receive the information. Mr. Doubt tells the processor that he can now pass the data. The processor, after knowing that display data is free, rushes to pass the data to her. The processor tells display data to place the data in her register, which would then be displayed on the monitor. However, the processor will not be doing any useful work when he is checking for the status flag. So what can the processor do so that he can do useful work until there is a need for an input or output? This leads us to interrupt-based. Interrupt-based uses interrupt signals, which is a hardware signal. The signal will be off when there is no input-output required. This will allow the processor to do useful work and not check for the status flag only. When the interrupt signal is on, the processor had to stop doing his useful work and start the input-output operands. To summarize, there are two input-output handling approaches: program control input-output and service interrupt. In program controlled, the kin flag is initially set to 0. However, an input from the keyboard will set the kin flag to 1. Thus, there is data in the keyboard data that the processor will collect. After that, the kin flag is set to 0 again. After collecting the data, the processor will be trying to pass the data, which Doubt will prevent the processor from doing so. He will call display data to check whether she is free. If she is free, Doubt will allow the processor to pass the data to her, after which the processor will tell display data to put the data in her register so that she can display the character on the screen. In interrupt signals, the processor will be able to do useful work and not check for the status flag constantly when the interrupt signal is turned off. If the signal is turned on, the processor has to stop doing his useful work and start his input-output operands. And that's all for this topic. Thank you for listening.
Created using Powtoon.